Hello students, we'll continue with this specific modules for the class. In this one we're going to continue on with this feature called constraints. So previously we've already covered how to start a sketch, how to create lines, circles, rectangles, different shapes, and then on top of that we started with dimensioning. So now we're going to continue on with constraints. So here's some of the things we've done and some of the things we'll do. So we've already started drawing. We know how to do that, how to use the drawing tools like I mentioned, dimensioning, and of course today we're going to start on geometric constraints. Okay. So what I'll do is I'll first go into Fusion and I'll take a look at what's happening here. So we have our project, which is called Summer 2020. Everybody should already have a project like this. Now what I did is I started a new folder and I put all of the different activities into weeks, similar to what we have on Blackboard. Okay. So what I'm going to do today is I'm going to start a new folder so I can actually input all of the different activities for this week. So I'm going to go into new folder and I'm going to call this week 2. Press enter, and then I'm going to go into week 2, and this is my first activity, if you will. Now sometimes depending on your preferences, as they're set in Fusion, you might have things showing up here in your environment like a grid and axes. Sometimes you don't, so all you have to do is just make sure that if you click this icon here, make sure that the layout grid is checked. That way you can see that background in there. Okay. Now what I'm going to do today is I'm just going to do very simple examples on a sketch, and then I'm going to go through the different geometric constraints that you can use to actually constrain these different sketches. Okay. So I'm going to start a new sketch, and then let's first talk about the constraints that we have. So we have horizontal vertical constraints, coincident, tangent, and then equal, parallel, perpendicular, fixed or unfixed. Now this one, I think I mentioned that before. Try not to use it ever. We consider this sort of a easy way out of solving an issue. Okay. So try not to use fixed or unfixed. All that's going to do is that's going to fix something in space. Don't do that. Okay. Instead, try to use one of the other constraints and dimensions to do that. We have midpoint, we have concentric, collinear, symmetry. We can use it, we don't really use it that often, and curvature, which also we don't use it that often either. Okay. And then what I want to do here is I want to first start with a couple of examples. So let's start off with a line like so. Okay. Now this line, as we all remember, we need to have a couple of things for fully constraining a sketch, right? So the first thing is it needs a position in the X. So this line can still move left or right, up and down. So it's missing position X and position Y. Okay. Now what I'm going to do is I'm going to give it a position X as sort of a coordinate. Okay. So what I'm doing here is I'm giving it a distance from the origin to this point. Okay. I don't know, let's do that 20 millimeters. Okay. So now this line can no longer move left or right, but it can still move up and down. Okay. So I'm going to remove that from happening. So what I'm going to do is I'm going to do a vertical like so. I don't know, 45 millimeters. And now what I've done is I fully defined this specific point here. Okay, so this point can no longer move left, down, up, right. Okay, so now what's going to happen is this point is still free to move, right? So the entire line can still rotate, and the line itself can still extend or retract. Okay, so what needs to happen is I need to make sure that that doesn't happen. Okay, so we have position X, we have position Y, The other thing that I need is a size. So in this case, I'm just gonna give it a specific size, like so. And I'm gonna say this is, I don't know, 75. Now, be careful when you are adding dimensions like this, because as you can see here, the dimension that I added here is just an X direction. It's not the actual length of the line, okay? Now, if you wanted the actual length of the line, then when you first press D and select the line, you just have to sort of be careful with it. So this is the X, this is the length, and this is the Y, okay? So I want to give it the length, so something like that. Make sure that's 75, okay? And then I'm gonna move this up a little bit. Now, the only thing that this line is missing to be fully dimensioned or fully defined is it needs an angle, right? So what I'm gonna do now is, instead of giving it an actual angle like we've done before, now I'm gonna use these constraints to sort of do that for me, okay? So let's first focus on the horizontal vertical constraint, okay? So what I want to do is, I have two options. Either I can make this line horizontal like so, or I can make it vertical, okay? Now, if you wanted to do that by using the constraint, first thing you would need to do is select the line and then select the constraint you want to use. So in this case, horizontal vertical, okay? Now, notice that if this line is at this position or this angle, then it's going to move up into a vertical instead of down into a horizontal, okay? The reason for that is it combines the two constraints into one. So it combines both the horizontal and the vertical, okay? So what happens is Fusion automatically moves to whatever's closest to the current angle of the line, okay? So in this case, the line is closest to a vertical, so it just goes into a vertical. Whereas if it was probably down here somewhere, then it would just go down to a horizontal, as we can probably see here. So let's select the line, horizontal, vertical, then it goes down to horizontal, okay? So this is one thing to be careful with, because if you have a line that's pretty close to a 45 degree, so something like that, then it would probably wouldn't know where to go, and it would just pick one of the two. So in this case, it picked horizontal, but it can be either horizontal or vertical, as you can see here, okay? So just sort of be careful with that, okay? So that's the first one. So what I'm gonna do is I'm just gonna delete that line for now. I don't need that. Now what I'm gonna do is, now let's move on to the next one. So let's do this thing called a coincident constraint, okay? So the coincident constraint, what it does is it essentially makes two things coincide, okay? So in this case, we have a gap, right? So we have a gap between this point and this point. We don't know where they should meet. So coincident constraint, all you have to do is select that and then select the 2 points, and then it's just going to join them together, okay? So that's coincident constraint, okay? Then we have, so let's skip a couple of them. Let's continue on with this example. So here I already have a horizontal constraint, and then I have 2 perpendicular constraints, okay? So by definition, if this line is horizontal, then this line has to be vertical, right? Because of the perpendicular. And then if this line is vertical, then this has to be a horizontal because of that perpendicular constraint as well, okay? Now there's a couple of ways. So if I wanted to make this line vertical, there's a couple of ways I can do that. So I can just select the line and then select horizontal, vertical, or I can probably select perpendicular and then select the 2 lines like so, making this 4th corner perpendicular as well by definition, right? Or I can probably do something like a parallel. So make this line parallel to this line, because they both should be vertical, right? So again, you have multiple ways of constraining something that results in the same thing. Okay, so in this case, I just showed you, I think, like 3 different ways to reach the same result. Just sort of be careful with that. Okay, now that we're here, do we know if this is a square or if this is a rectangle? Not really. They're both the same. The only difference between a rectangle and a square is that a square has to have all 4 sides being the same, right? Whereas the rectangle just has to have the opposing sides being the same. Okay. Now, what we need to do is, if we wanted to have a square, then we can probably use the equal constraint and make 2 consecutive sides equal to each other, right? So as you can see now, this side is equal to this side, and by definition, all 4 sides are the same. So now this is a square. Now all I needed to do for something like this is give it a dimension, and we're still missing position X and position Y, but we already have the size for everything, right? So if we wanted position X, position Y, then we can probably do something like this and something like this. Okay, so position X, position Y, size, and then the angle for everything. Now everything has a size because all 4 sides are the same. Everything has an angle, so horizontal, perpendicular, parallel, and another perpendicular, so everything has an angle. Okay, so that's a couple of more constraints down. Now let's carry on. Let's do probably something like a tangent, so something fairly simple. Okay, so what I'm going to do is I'm just going to create a circle. So I'm going to create a circle here at the origin. Okay, and then what I'm going to do is I'm going to type L for line, and I'm just going to make a line like so. Okay, now let's first define a couple of things. So the circle itself, it has a position because it's starting at the origin, so this circle cannot move. It's just sort of missing that size, right? So what I'm going to do is I'm going to give it a dimension. I don't know what a good number is, so something like 70 maybe. And right now the circle is now fully defined. Okay, so anytime you have a circle, you only need 3 out of the 4 items to fully constrain, fully define. Those 3 that you need is position X and position Y. So as you can see here, my position X is 0, my position Y is 0, and size. That's the only 3 things you need. In this case, I'm giving it a diameter of 70 millimeters. Now you don't need an angle because a circle is the same regardless of how you take a look at it, right? So we can flip this entire view 90 degrees this way, and the circle is still going to be the same. Okay, so just sort of keep that in mind. Okay, now once we have this, then let's try to define this line here to sort of touch that circle. Okay, there's a couple of ways we can do that. We can probably define the location of that line this way, by just doing like a radius of the circle. So if we wanted to make sure that that line is touching that circle at a specific point, so let's say like right here at a 45-degree angle, then the easiest way to do it is probably just do a tangent like so, and then just make sure that this line here is at a 45 from the X. Okay, so there's a couple of ways to do that. Again, it all depends on what you want to do. Okay, in this case, a tangent, all it does is, like you can see, it makes a line tangent to a circle, or 2 circles tangent to each other, whatever it might be. Okay, so pretty straightforward. Okay, let's see, there we go. And just to show you, I'm gonna remove that, and then I'm gonna make another circle. I can probably define the size, so something like 50, and then just make the 2 circles tangent to each other. Okay, now no matter where this circle goes, it's never gonna go into the other one because it's always gonna keep that tangent constraint. Okay, so that's tangent. let's see what other one we're missing. So we already showed you equal, we already showed you parallel, we've already shown you perpendicular. Let's do concentric. Okay, so concentric, all it does is it just matches the center points of two different circles into one. Okay, so in this case I have something like that, and then I might have something like this. Okay, so very similar example as before. Here we can see the center point of the bigger circle, and this is the center point of the smaller circle. So when you do concentric, this circle to this circle, all it does is it's just matching the two centers into one. Okay, so a circle within a circle, if you will. All right, so that's fairly simple. Okay, let's do midpoint. So midpoint is sort of hard to use at the beginning, but you can get used to it pretty quickly. Okay, so what I'm going to do is I'm going to create a line like so, 90 millimeters, and then I'm going to create another line that's sort of horizontal from it. Okay, now this line, let's give it a dimension as well. Let's make it, I don't know, 70 seems about right, except I'm going to move this line to the left a little bit and down. Okay, and then let's see what center point does. So we're centered. There we go, midpoint. So midpoint, this line to this line, it's just gonna move it, and it's gonna make sure that this line here is matching the center. So both centers, if you will, become one, similar to concentric. Now, midpoint sometimes can work a little bit different, because you might have something like this where you already define this dimension here. So now it's no longer going to look for the middle of this horizontal line. Okay, but midpoint should still work to a specific extent. See, sometimes it likes to cooperate, sometimes it doesn't. So you just sort of have to be careful with it. I'm not sure why sometimes it does it and sometimes it doesn't. My guess it's probably just because sometimes depending on how you select things, you might be able to do something like that. Some other times you might not be able to. Okay, so midpoint, just sort of be careful with it. Usually this is what it does. Just sort of expect that. Okay, so it matches the two centers from each of the two. Okay, and that's pretty much it. Oh, collinear you might need as well. So let me trim away some of these things. Collinear, so let's say you have something like this, and so again I'm just making up some stuff here. Okay, now let's define this thing. So I want to make sure that all my angles are 90 degrees, and then let's give it some definitions or dimensions. Now this line here, if I wanted to make sure that it's at the same level as this line, I would probably use this thing called a collinear constraint. Okay, so what collinear does is it extends an imaginary infinite line on the first line you select, and then it matches the second line to that first imaginary line, if you will. Okay, so something like this to this, it brings up the second one to the same level as the first one. Okay, same thing the other way around. So some of these things you have to be careful with what you select, as that's what's going to bring things down or up. Okay, so there we have it. That's collinear. That's pretty much all of them. Horizontal, vertical, coincident, tangent, equal, parallel, perpendicular, fixed or unfixed, don't use, midpoint, concentric, collinear, and then symmetry and curvature, you can try it on your own. They're pretty intuitive as well. We don't use them that much, so that's why I'm not showing them to you. Okay, so we'll stop here, and then we'll carry on with the next video. All right, see you later.